In this video, we are going to discuss about direct memory access, DMA. It is a special control unit, which is a DMA controller, may be provided to allow the transfer of block of data directly between an external devices and main memory without continuous intervention by the processor. So this approach is called as direct memory access. DMA controller is a part of a input-output device interface. It provides memory address for each word transfer, and it also provides all bus signal that control data transfer. So it has a it provides a memory address for each data word transfer, right? So generally it transfer the block of data. In order to keep track of number of transfer, it has to provide the memory address location. So this DMA controller operation must be under the control of program, though there is no intervention from the processor. It should be under the control of the program which is executed by the processor. In order to transfer the block of data, the processor first send the starting address and the number of words in the data, that is word count, and the direction of data transfer. So it will be a read bar write signal. Whenever the read signal is on, it will read the data from the memory. The input output, the input interface will read the data from the memory. If I want to write me, so it is in the opposite direction. So based on it, the DMA controller will operate, right? So you have one more register which is called the status and control register. It consists of 0 to 32 bits. The first bit 0 is nothing but done, and first bit is read bar write, and 30th bit is interrupt enable, and the 31 bit is IRQ. So once the entire data get transferred, the DMA controller will send the processor IE signal. The IE signal gets 1. Generally, the DMA transfer is high priority compared to the processor that requested the transfer. So once the DMA controller will transfer data get completed, then the processor can return to the program that requested the transfer. So it can be done with the help of the OS. Here, then OS is responsible for suspending the execution of the program and starting the another. So here these two are the DMA control register, which can be accessed by the processor to initiate the data transfer, and third register is status and control register. So this read and write will read the data from the memory and write the data into the memory. So it will tell the which direction the data get transferred. Okay. So after the IE bit goes to 1, that is this is 30th bit, right? Controller will set the IRQ bit as equal to 1 when it has requested a int. So this is uses of a DMA controller. Here you can see there is a processor main memory that is connected to a system bus, and other end of the system bus is connected to a DMA controller, and it consists of disk 1, disk 2, and here you can see the DMA controller is connected to a network interface. Likewise, we can connect a graphical display unit extractor. So here we can see the high priority is given to disk high speed network interface graphical display devices. So this DMA controller connects the high speed network to the system bus. So here the system bus implies data bus, address bus, and control bus. So the disk controller will control two disks, disk 1 and disk 2. And it also have the DMA capability, and it provides two DMA channels. So therefore it can perform two independent DMA operation if each disk it has a own DMA control. So there is a register which is used to store the memory address, word count, and etc. So that is present inside this DMA controller. So the DMA controller has uh, for uh, for storing the address, it requires some registers, and to store the word count also it has another register. Then it has a control unit also. So whenever the DMA transfer a block of data from the main memory to one of the disk, the program will write the address and word count information into the register of the corresponding channel of the disk control. So it also provides the disk controller with information to identify the data for future retrieval also. This DMA controller provides independently to implement the specified operations. So next one is cycle stealing. So whenever the processor originates it will occupy the most memory access cycles. So the DMA controller will can be set to steal the memory cycle from the processor. So this intervening technique is usually called as cycle stealing. Next one is block or burst mode. So the DMA controller may be given an exclusive access to the main memory to transfer the block of data without interruption from the processor, and the speed of the transfer of the data from the DMA controller to the main memory which is take place on at a burst mode speed. A conflict may arise if both the processor and the DMA controller are two or more DMA controller tied to use the system bus at the same time to access the main memory. In order to solve this, we are using for a bus arbitrage procedure, which is implemented to coordinate the activities of all devices which is requesting the memory transfer. There are two approaches of bus arbitration. First one is centralized, which is also called as single bus arbitration, and distributed bus arbitration. First, let us discuss about centralized arbitration. So here the priority is fixed. That is, you can see I have two DMA controller. So the BR is a bus request signal. Whenever the input devices want to access this bus, it will send the DMA request, and DMA controller will send back DMA acknowledgement signal. Therefore, here all the DMA controller is sending the bus request signal, which is active low signal. Once the processor identify, so this the processor will send the bus grant signal to the DMA controller. Okay, this signal represent the bus busy signal. Okay, so here the priority is given to BR1, that is DMA controller 1, 2, 3, 4, etc. And there is also concept called rotative priority also used. Suppose first we are using DMA controller 2, that is BR2, then BR3, BR4, then it comes to the OR gate, that is BR1. So therefore it is very fast, but the hardware complexity is higher compared to daisy chain method. So the daisy chain method is nothing but a distributed, the channel is distributed across the devices. Therefore it is lower speed compared to the centralized one, and it has a lower hardware complexity, and it has a fixed flexibility. There is one more mode in the DMA get operated that is called as transparent mode. Here the DMA works only when the CPU is not using the bus. So it is also called as background mode. So whenever the any one of the suppose the DMA controller 1 is allowed to initiate the data transfer on the bus at a given time. Therefore, this is called as bus master. All of the devices act as a slave. So once it is transfer the data, okay. So once it get completed, the priority based on the priority, the next one will get executed. So therefore, the bus operator may be a processor or a separate unit which is connected to a bus. So before the bus master is assigned to one of the DMA controller, the processor will be act as a bus master. So the DMA controller indicates that it needs to become a bus master by activating the bus request signal. Okay. So the signal on the bus request line is the logical OR of the bus request from all the devices which is connected to it. So whenever the bus request is activated, the processor will activate the bus guarantee signal, which will indicate the bus is free. Okay. So this signal is connected to all the DMA controller with the help of this daisy chain arrangement. So whenever the first DMA controller is requesting the bus means it will block the propagation of transmitter to all other devices, right? So for the all other devices, the bus BC signal will be activated. So once any one of the DMA controller receiving the bus grant signals, so it has the other has to wait for the bus BC signal to become inactive. Okay. So the arbiter circuit will ensure that only one request is granted at any given time according to the priorities key. So I have already mentioned the priorities, right? So this is how it will work. The advantage of the DMA controller is it is very simple, the hardware wise, and it is easy to expand.